Okay, this is another video showing solutions to midterm number 1 review problems. And this is John Marsh, and I'm on problem number 7. And this kind of goes with the last video, and it asks about Boolean functions. Consider Boolean functions with domain 0, 1 raised to the kth power and range 0, 1. That means it's a Boolean function. What is the size of the domain, and how many possible functions are there with this domain and range? And this one really builds off of the example from number 6, where we were mapping 0, 1 squared as the domain, and we found that there were 2 squared possible inputs and 2 raised to the 2 to the 2 to the 4th, or 16 possible functions. And as covered in class, the size of the domain, put vertical lines around it like an absolute value sign, is equal to the size of the set, 0, 1 raised to the kth power. And this is also equal to, let's write it all out in detail, the size of 0, 1 itself raised to the kth power. And this is, the size of the set 0, 1 is obviously 2, and so we have 2 to the k is the number of elements in the domain. Okay? That's what I had written here before, but I'm showing an extra step. And finally, the number of possible math functions, the number of possible Boolean functions is 2 raised to that power. 2 raised to the size of the domain. So it's 2 to the 2 to the k. Okay? That's problem 7. If I move on to problem 8, we're considering this Boolean function. Make a truth table, and which of our standard functions is 8 equivalent to? I'm going to go very quickly through these truth tables because I think most of you know how to do them. And basically I'll show them here. Here I made a truth table all at once. And I wrote the whole function up top here, and I did it in multiple steps. First I did a not p column, then I did a q column, and then I ANDed these 2 columns to get q and not p. And then I did a not q column, then I did a p column, and I ANDed them to get this other middle column. And you can see that each column of numbers is underneath the thing that it's talking about. And so finally these 2 columns were ORed together to yield the final answer, 0, 1, 1, 0. And that's like an XOR, 0, 1, 1, 0. Okay, problem number 9, very similar. Oh no, problem number 9 is a disjunctive normal form. We're given the truth table here, and we're supposed to write down the disjunctive normal form for this function, and we're supposed to eliminate all AND operators using De Morgan's laws. Okay, so disjunctive normal form. The idea here, I've copied down this definition for the function here. The idea of disjunctive normal form, as we've gone over in class, is to find all the rows where we have a 1. And we're going to say that f is true either when we have this case, or this case, or this case, or this case. Precisely those cases where we have a 1 on the output. So we're going to say f is true when we have first case, or the second case, or the third case, or the fourth case. And each of those cases is easy to write. Here we see that the first case is p has to be false, q has to be false, and r has to be true. Not p, and, not q, and r. Similarly, not p and q and r, or p and not q and not r. Finally, all 3 true, p and q and r. And so we have 4 1s in the column, and so we have 4 things that we're ORing together. And now you can see that now what we want to do is eliminate all the AND operators. And the AND operators are on the inside here of these 4 pieces. And so I'm going to apply De Morgan's to each of those 4 pieces. And what I'm going to do then is on the first one, for example, I'm going to put a big minus sign on the outside. I'm going to flip the sign on the P and the Q and the R, and I'm going to turn all the ands into ors. Okay, so you can see I've done that. And here I had a double negative on P, which turned it back into, I had a double negative, which turned it back into P. And I flipped the sign on the Q, and I flipped the sign on the R. And I do the same thing for all the others. I put a big not symbol out front of the big parentheses, turn them, the ands into ors, and flip the signs on the P and the Q and the R. And that does it. Problem number 10 asks us to take the Boolean function which is given to you in disjunctive normal, form, and to create the truth table for it. It's easy to do. Rewrite it using only not and rewrite it using only not and or. It's going to be the same trick I just pulled with the De Morgan's law. So here's number 10, and here we see, here's the function I've copied in I've labeled as disjunctive normal form. Here's the truth table. Basically, I've got 4 chunks ORed together. This needs a parenthesis here. And in those 4 chunks that are ORed together, that means I'm going to have 4 ones in my output. And I have P and Q and R, so I'm going to make 8 rows with P, Q, and R. And I'm going to put 1s in those 4 rows where these things hold true. And in the first one, P is a 0, not P. Q and R are both 1. 0, 1, 1. 0, 1, 1 gets a 1. Not P and Q and R. The next one was a 1, 0, 1. 1, 0, 1. P and not Q and R. The next one is a 0, 1, 0. This row up here. The not P and Q and not R. And finally, we have a 1, 0, 0, which is here. And so those 4 rows get 1s, and the rest of the other rows get 0s. Now I'm going to do that trick with applying De Morgan's. And I can apply De Morgan's a couple different ways to this function. You see that overall, the function has the form of one thing ORed with another thing, ORed with another thing, ORed with another thing. And I can apply De Morgan's to that by flipping the sign on all of these things, flipping the ors to ands, and then putting a big minus sign outside of the whole thing. So here's my big parenthesis now on the whole thing. And that's what De Morgan's does. And so I can use that to eliminate all of the ands on the inside of these individual little pieces. And here I've done it. I'm sorry, I can use that to eliminate these ors. I'm going to turn all these big ors into ands. And that'll leave me with nothing but ands and nots. So I put a big parenthesis with a not on it around the whole thing first. And then I put knots in front of each of these pieces, and each one has 3 things on the inside. And I have to be careful to copy them down correctly. And let's see, I'm going to leave them the same, and I'm just going to put knots out in front of them. So I put not out in front of the first one. I put a knot out in front of the second one. I put a knot out in front of the third one and a knot out in front of the fourth one. And now I'm left with nothing but knots and ands. I can now do the same trick if I want to eliminate the and statements. I'm going to do De Morgan's. Instead of doing De Morgan's on the whole big structure, I'm going to do De Morgan's on each of the little inside terms. And so, for example, P and Q and R turns into a not on the outside with a not P or a not Q or a not R. And so I'm going to leave the structure, the overall structure, the same. 4 things ORed together. 4 things ORed together with 3 big OR statements. And I'm just going to put a minus sign on the outside of each of these little things, and I'm going to flip the signs on the inside, and I'm going to turn all the ands on the inside into ors. So the first term is a P or not Q or R. P or not Q or R. The second term is going to be a not P or a Q or a not R. Not P or a Q or a not R, etc. with a big not outside, flipping the sign of the P and the Q and the R and turning all the ands into ors. And so here's the final solution to that one. And I think I'll stop there.